It's just confirm whether it's getting recorded. I, am I audible?
Yes, you are audible and it's getting recorded.
Okay, okay. Yeah, we can start now. So our first question is like rank transform of an array. So we are given an array of integers and we need to replace each element with its rank. And the rank represents how large the element is. There are set of rules which they are following. First of all, it will start from integer 1, and the larger the element, larger will be the rank. In case the elements are equal, their rank will be same, and we need to rank should be as small as possible. If you look here, so your 40 is the largest, so 4 it has been given. Then first largest is 1, second is 2, and 30 is 3. So that is the rank given to it. And here, since all are duplicates, so 1 1 1, and same goes here. Like 80, if you see, that's the largest one. This is the fifth largest. Then 12 is the third largest. That's why again 12 is here. So 3 and so on. It's like that way only. And these are the constant, like array length will be less than 10 raised to 5, and each element will be less than equal to 10 raised to the power 9. Yeah. Yeah, any queries in the question or approach?
I don't have a solution ready, but what I was thinking is to fit a heap somehow this.
Heap,
Yeah,
yeah.
because we have to calculate a rank, and if we
Mm.
construct a heap somehow and construct a heap based on the input, and maybe while polling or while taking out the element from the heap, we can figure it out with some logic around something like that.
Like
I was thinking.
if you take max heap, so when you take out 40 and you take the length of a heap, right?
Yes, something like that.
Then
Yes.
your 40 would be assigned the length for last one and so on. And when you pop one element out of the heap, you decrease the length also of the, what do you say, length of the heap.
Yes.
And
Yeah, I will put it in a priority queue and keep on traversing using a
mm,
comparator. Element should be greater. It means element first element a minus b or something like
yeah,
that. Yeah.
yeah,
Yeah, actually, I tried that way,
yeah.
with the heap. But when you go for the, I think the example 2 here, when
Duplicate.
all your inputs are 100, 100, 100, so you won't be able to get 1, 1, 1. That is a problem.
Yeah.
So, because I also thought it was very intuitive, right? Just go for a priority queue, the way I think Raghav said, right?
Yeah, yeah.
But it didn't work. It didn't work for this test case.
Duplicate elements.
Yeah, if they are duplicates, it doesn't work. Yeah, here also in the example 3, when you have
12,
yeah
12.
two 12s, right? So there also it
Yeah.
fails. So if we can tweak some way, then I think that might be usable, but I'm not sure how to do that. Maybe it's not an easy way to do it, or so something.
Yeah.
So,
Why did it not work for 100? Like when you can insert in the queue and while polling, you compare what was the previous element. And if it is same element, you assign the rank as same rank.
Okay. Yeah, maybe the way I did is when I was actually pushing in the queue, I was pushing the element along with the index. So I should not have done it that way.
I mean,
So maybe
you
that was
should.
an issue. Yeah.
Mm,
but
Then
like
got confused.
index. Go ahead.
building a heap would be like n log n, right? Or
Exactly. Huh?
it's as good as
Then
sort the array, and that is
sorting
also
the
n
array.
log n. So
Right.
what is the advantage of taking and removing an element from heap will also again,
is-
I'm just trying to throw a different idea, like how to think, like how if I take a heap, still it would be n log n, and sorting array would be also n log n.
Yes, yes. Yeah, that is right. But I thought like when you start with one solution, when you start in an approach, you would like to pursue that till you don't find a problem, what the issue is, right?
Yeah, yeah, yeah.
So that's the way I just went, and then it didn't work. So yeah.
or while making the heap, if you could have taken set, then only unique elements you would have entered.
Something like that.
And let us
But
I
I think
think we can use hash map with sorting, and after just sorting the array, we can put the values rank values corresponding to the keys
element.
in hash map.
Yeah, that also works.
yeah,
Yeah.
that is a good way of doing it. Yeah.
Sorting will take,
Very
I
good.
think, n log n, and searching in hash map is not is constant time, so I think it will work fine.
Yeah.
Yeah, sure. Only extra space you are taking for hash map. Yeah. This is the same approach what he was discussing. Simply, I'm taking initially set just to get only the unique elements, creating a dictionary, and this is your result array. And I'm sorting it and starting index from 1. So corresponding to each element, I'm assigning their position. Like if 40 is there, then 4 will be assigned to his 30, 3, 2, and 1. And this is just iterating through that and taking the value out of this. Corresponding to that key, what rank is there, and just return the result.
So basically, you're putting the
A position along with the key inside the dictionary. Like if let's say I sorted it in ascending order, so 10 will come. 10 is at one position, so here 10 will be there and 1 will be here.
so
Then
first
20.
you put that in a set, and then you sorted that set.
Exactly. Huh?
Okay, and after that, you're going through each element of the set.
Of that sorted array.
Sorted array or sorted?
Sorted array. You will have after getting the unique elements, you sort them. You will get it in a new variable called sorted array, and
Okay,
then
so now
corresponding.
that won't have any duplicates, and they are sorted.
Exactly. Yeah.
And then you're picking. So then
Now I'll go
you're.
through the
Uh-huh.
initial array. Every element I'll go because only one time I put this 100 in the hash map. So corresponding to 100, let's say if I have 1, then I'll put 1. Again, if I encounter 100, I'll put 1. Again 100. I'll look into the hash map 100 and corresponding rank. It's
So
like
so in that case, I was.
let's say initially sorted is like 20, 30, and 40. So corresponding to 10, its position is I'm starting position from 1. So 10 will have 1, 20 will have 2, and 30 will have 3, and 40 will have 4. Now I'll go through this array. In this array, I'll see 40, look into the hash map, and in the result I'll append 4. Then I'll go to 10 and result 1, and whatever. Then 20 I'll go. 20 is 2, and then 30 is 30 is 3. This is what I'll return.
Okay.
But do you need to use set? Because actually that is, I think, might be an additional data structure to use. You could have actually, someone said, right, modify the comparator in the sorter, in the sorting, and then you can actually take care of the duplicates. Because here you are using set just to remove the duplicates, right?
Exactly.
Yeah, just a thought. I'm
So,
not sure.
or it is could
Comparator.
be a tree map in Java. So that will give you in the sorted, and then we are basically taking the position where it belongs in the map.
Yeah, this map, this gives you the position. Because of that only the use of mappings. We can use BST also if we create a binary search tree out of it. And index is I, and left index will be what, 2i, and right index will be 2i plus 1. We'll treat that BST as a, what you say,
Yeah.
unique. Yeah. So in that you don't need to keep track of index.
But
Because all,
in your map, I think dect underscore a is your map, right?
yeah.
So when you are actually iterating through that and putting all those information in the map, that itself you could have checked whether it's duplicate. Putting an if statement
Yeah,
over
that
here.
also. Yeah, if it is
Okay.
exactly. There I'll check if it is already present, then I don't need to append it again to the. Yeah, yeah, that's nice one. Wait, will this cause any harm or what? Like
No, no,
using
no.
it for
No,
data
I'm
structure?
just thinking loud. Nothing. I'm not
Yeah.
even saying whether it is required or not
No, no,
required.
like,
But
is
I was
it
just thinking
taking extra
adding an additional
space?
data structure.
Data.
I'm
Oh,
not
okay.
sure. Yeah, because you're adding another set, right? So the minimal number of data structures you add, it is always good,
Better.
because less overheads. I'm just thinking in that
Oh,
direction. Yeah. But yeah, your
yeah.
solution is very good. It's not a problem. But
One
that's
more
No, no,
point to which I would like to add in Java, hashmap doesn't allow duplicate values to enter in that.
I'm not sure about Java.
hash map. Okay.
Yeah, that's what I'm telling. I'm sure about this. Sure. Art. Go ahead.
Okay. Okay. So we should always try to avoid excessive data structures, right?
No, no, that is my thought process. I'm thinking about that. I'm not sure whether it is good way or not. But I just saw set and said, okay, maybe because you're using sorted as well as you're going through this iteration, right? Anyway, you're going through the whole array again.
Yeah.
So that if you
Mm.
could just use a if statement and avoid that. So your whole purpose of using set was just to remove duplicates. So I thought maybe this could be done in this way also.
But one thing will be like, if you don't use set, then again this for loop will increase, right? I mean, let's say initially we had 10 elements, so it will shorten to 5. Let's say 5 were duplicates in that. But if all the 10 elements will be there, then again for loop will run for 10 elements. So theoretically order of n only time complexity, but practically it's the computation is increasing, right? I'm avoiding that computation here.
Yeah,
Every element I have to visit. Yeah.
that makes sense too. Yeah. Yep.
Yeah. Okay. Then let's proceed to next. Okay. Yeah, it's a combination one. We are given two integers n and k, and you need to return all the possible combinations of numbers out of 1 to n. So there are four numbers, and every two you have to select. So 4c2 is 6. So 6 possible. This will have 2, 4, 3, 4, these combinations. Yeah. Yeah. Any queries or approach in this?
They didn't mention what it could have. The array could have duplicates or not. No, it is just numbers, right? One.
Yeah. Yeah. 1, 2, 3, 4. Duplicates like same set, like 2, 4 and 2, 4 again. You're telling.
No,
No, no,
like
no.
1 1 2 2 3 3.
Okay. Okay. Yeah. That number will be unique. 1, 2, 3.
Can you take an example for where n is
Yeah.
4 and k is 2? So how it will look like?
Yeah, like this. What I think this I have 1, 2, and 3, 4. You have then first two you take combination 1 with 2 you can have, then 1 with 3 you can have, 1 with 4 you can have. So this got over. Now you take 2, 2 with 3 you can have, and 2 with 4 you can have. Now take 3, 3 with 4 you can have. So these are the 1, 2, 3, 4, 5, 6. I think 3, 3, yeah, 6 possible combinations.
So here order matters. So 1, 2, and 2, 1. We cannot do the 2, 1, right?
Yeah, 2, 1 you can't do. 2, 1 if you do it is same only 1, 2 and 2, 1. I mean, it's like normal combination, like out of two things, like A and
Okay.
B are person and pencil you are giving 1 to A, 1 to B, or the other way around you are giving. Both are same only. Arrangement doesn't matter, only selection matters. Whether you give one pencil to A or that pencil to B, or the other one, or the vice versa if you take. So both are one in the same.
Okay.
Yeah.
Well, I didn't solve this problem at all. I didn't try also. But the way you are
Yeah.
explaining, you
Yeah.
could do it the same way, right? You just use a for loop, start from the first one, like 1, 2, 3, 4, because you have n numbers, right? So you start from first
Exactly.
and just I use
Mhm.
another nested for.
Yeah.
I'm sure that it will be more in terms of time complexity, but
TLE it might hit. Yeah. Mhm.
will it hit or will it work? I'm not sure.
I
Because anyway, the
I
solution will be n square, right? For whatever the way you go.
yeah, yeah. Mhm. But if you see your what you say, this limitation is they haven't given. If n is very high, I mean, like
Yeah.
then in that case, I think it would be worse, right? It will
Uh,
work. Yeah, two for loop. What I mean, first element you take iterate from 2 to 4. Second you take 3 to 4. Again, this to 4.
because you have to still find all the combinations. So you still have to iterate through the whole array, correct?
So
Yeah.
looks like, I mean, the normal, the problem to generate all the permutation. So here in that the termination condition is that when we actually exhaust all the number, but here the termination condition is that when is equal to k. So that will be the
Yeah.
termination condition. So looks like we
That.
just
Yeah.
fix the number at that position, and then
Mhm.
and somehow we need to actually eliminate that as if 1 2 and 2 1, that is a duplicate, so we need to handle that case maybe using the dictionary.
It's
If we go in, we traverse in increasing order, from 1, 2, 3, 4, 5, for example, we would not see the case like 2, 1,
yeah,
right?
2 1 you won't have in that case.
Yeah, I
Because
agree.
mm,
I agree to Leon in that, yeah.
mm,
So, but as Praveen was saying, so is this going to be somewhat like a top-down approach, some dynamic programming approach?
That's just like a backtracking.
Okay.
backtrack, yeah.
So these are one
Maybe.
particular set of things which goes by backtracking, and in these kind of things we can't care about complexity. These questions goes really high on the complexity.
Okay.
So if you so one once I was trying some similar question, I was thinking about complexity first. But if I think about complexity for this question, then the solution could not be reached because the solution itself need a really crazy tree because you're trying
Yeah.
different combinations.
Mm-hmm.
If you're just giving a number,
Exhaustive search. Yeah. Yeah, yeah, yeah. Go.
no, I was just telling if you're just giving some output as a number, then we could think about optimization. But here we have to try different combinations. So yeah, that's the catch.
I mean, after doing backtracking, you can try some pruning if somewhere you can avoid some of the nodes, something like that. Like what Praveen was saying, once you get a length, you return back from there. We don't need to proceed further. So what I like, and one is thumb rule. Whenever you see problems like permutation, combination, for any selection stuff, we should give thought to this. What do you say? Backtracking. So what I was doing, I'll just
So is it like you are saying whenever there are combination or permutation problems, we surely have to give an
Backtrack.
thought process for
Thought to backtracking.
for
Yeah.
backtracking, and
Exactly.
most probably it might work. That is what you're trying to say.
Yeah. I mean, there could be other methods also, but it's a pattern that I've observed. Like whenever you have permutation, combination, or where you find that you can't come up with any genuine, I mean, unique solution. You have to exhaustively find out all the possible, and then out of that, you need to select something. So
Okay.
backtracking works. Like once we have seen 3 is given, how many open and closed parentheses you have to generate.
Okay.
Yeah, left
I
and right.
think
So,
I seem also
yeah.
saying the same thing. Yeah. Okay. Good.
In this
Yeah.
case, when k equal n, we cannot do any pruning, right? We still need to
Yeah, then only
run the
one way.
whole
Only one way.
permutation.
Entire 1, 2, 3, 4 will be, that will be the only one string if k equal to
Oh
4.
yeah, only one.
Because all the 4 you are selecting. So it's like just a normal, like what I did. You have this number. I'll first visit 1 and I'll put it in my set, and next I'll call backtrack on the remaining, that is from 2, 3 and 4. Now I have 3 possible options. I'll go with 2 and I'll append 1 with 2, and at this point I'll check whether it this length is equal to your k. If it is equal to k, you will backtrack from here. We'll go for the 3 then I'll select 3 again. If this your length is equal, go for 4, 1, 4, and once you find that you are done with this one, you'll backtrack to 1. So because you had called from here, at 1 you did a call to this function, so 1 is over, and in backtracking, like, you need to remove that once you have done. So we'll go for 2 next, and when you go to 2, you have two possible options only, 3 and 4. Like if you have 2, so either you can go with 2, 3, or you can go with what is it, 2, 4. So when this gets over, your function will return to this and we'll go for 3, and corresponding to 3 you have only one option, that is 4. Again you will backtrack and go to 4. Once you reach 4, after 4 you don't have anything, so your length will never be going to 2 here, right? So you'll return from the function will return from there. That's it. And only 2 things we need to remember in backtracking: when would you stop your partial solution? Like whenever you find, I mean, what Praveen was saying, like this length is equal to 2, that would be the case where you would stop and revert back.
Oh, so that will be a base case, right? So
Base case, yeah, kind of base case. Yeah. That is where you will stop. You're going further. Yeah.
Hmm.
Yeah. So it's the same thing what I'm doing here. So this is output. I am backtracking starting from 1. This is that base case I'm telling. If your the leaf, if it is equal to the length 2, then just to append to the result and return from back there. Otherwise 1 is over, then go for the 2, and this is where you are going for the 2. From 1 I started, then I'll backtrack on 2, 3, 4. From 1 you went to down, and you'll track on from 2 to 4, and every time you track you append this result, and again it will call, and so on. I mean, it's a standard, like a template, you can say. Whenever you do backtracking, first you write when would you append your solution. So this is the case for partial solution, and next time you need to remove that element on which you have already processed. So this is where you are removing the element. You are removing the ith element and going to the I plus 1. Any queries in this?
So in this solution for backtracking, we right? Normally we do like recursive, right? And keep going until we see the best case. We're thinking, could we do backtracking without recursive?
Could we do backtracking without, then that for loop what Santosh was saying, run 2 for loops, but no.
No, he's saying,
Backtracking
the
without
same backtracking, instead of doing the
Yeah.
recursive way, can we do it iterative way? Like maybe using a stack or something like that, right, Leon?
Yeah, here it's implicit stack they are using. Otherwise, they'll have to use extra
Yeah,
stack.
I'm thinking like using the for loop you know.
Okay.
So
But how you will use for loop, like if k is 3, like let's say k is 2, you will use 2 for loop. What if k is 3?
yeah, that's what I'm thinking, like kind of like the dynamic for loop. So the input not going to be, you know, two, we don't know, you know, what k is, but it's going to be dynamically. So I'm thinking maybe we can have like an array, you know, predefined array to keep track of, like, you know, that dynamic one. I see somebody post in the forum a while back, but I forget it now.
Maybe, you know, you use 3 for loops, right? First and second might be the length, which is equal to the k. You know, that will actually avoid the dynamism. So one you will have I, and other will you will have j, you know, and then you will have a length. What is the length? Because you start with 1, 2, 3, 4 till you hit k, and when you hit k, then you actually append it. But I think that
K
would
you
be
can
more
decrease.
complexity.
I mean, rather than using the third for loop, each time you run 2 for loops, decrease k by 1. The moment you hit 0, just inside that loop, see if k equal to 0, then that would be one of the, but I'm not sure.
But that will be, again, you'll have to use some recursive way. I don't think it will be done.
Yeah. Iterative, if you do, you'll have to use stack, I think.
Yeah.
Okay, let me look at, let me search for it, and then, you know, I post it.
Yeah, post
it in the Slack. Yeah.
But this is a very concise and neat solution. Yeah.
Exactly. Because every time you face a problem, these problems like this, you just follow. Like mnemonics one also, 4 mnemonics. What Asim was discussing, I think. We are having numbers corresponding to that letters were there. 2, 3 is there. Then you corresponding to 2 whatever characters, and 3 whatever characters you have. All possible combinations we are taking, right?
Right.
For 2 we had ABC, and 3 we have DF, AD, all those things. All those comes under the same domain, like if we have this one.
Only one small thing what I wanted to know. In backtracking, what we do is first we do a selection, then we go through that recursion, and then we again backtrack, right? Means actually whatever we decided earlier, we just go back. But in your case, you are not doing it here, right? So
basically, I think what is happening at line 14, it should first add in the current, and after that it should remove from the current. So if, but is it, I'm not so much sure about Python when we are calling it's call by reference or by value. If it is going by value, then line 14 is fine. Otherwise, actually the backtracking pattern is first you add it and then you remove it and then you go with the next option.
Oh yeah, so you are saying that the current plus I actually is being passed as a not by a reference, but it is passed as a value, right? Yeah.
Value itself, passed by value itself, yeah.
Yeah, so here it's actually every time it's actually creating the new string.
Yeah. I need to rush. I can put my code in the chat. So that's what it is doing. If you can just copy that.
Yeah, sure. So in Java, right?
Yeah, Java. Just from line 2, you can copy. You can remove line 2 to 5 and then copy.
Yeah.
So Sim, is there any way in Java to pre-allocate the array? Because you are actually adding every time and maybe removing. So if you just pre-allocate your output string.
So if I do, I have to create a new list. So what I'm doing, I'm reusing the same list. So what I can even do it line, Shank, if you can get a little down. Yeah, at line 23, I can even pass a new array list. Then I don't need to add and remove.
No, what I'm saying that though, I mean, it's not related with this problem. Just want to know that. So here at line 23 and 24, at 23 you are adding. So that will expand. That may expand your dynamic array, and 24 may shrink your dynamic array. So what I'm saying that if we know that what is the output for the current array, it will always be same as k. So if we pre-allocate that size, and instead of adding, just update the character at that location.
Yeah, that is also a good idea. Yeah, I got your point. Pre-allocate, and then like line 15, I have to do some other tweak.
Exactly. Yes. Yeah. So I'm thinking that like in C++, we can pre-allocate the vector, and then just update the value at that position and generate the string when it's equal to k. The k. Yeah.
Okay.
But this is like this is a list, so it's dynamic, number one, and secondly, your list for each of the recursion call, your size of the list the number will be varying, right? So that's why it's difficult to have fixed like update at specific position.
No, but we know upfront that the final size will be equal to k.
He has left, I think.
Yeah, I mean that's not related with this problem. I was just thinking that, I mean, how we can do that in Java.
Right.
Yeah, I think just create an array of integer of size k. Don't even need the dynamic one, right? Because we know they're gonna be k, and then we can keep the index on that integer array.
Yeah, but I think they are using list to return.
No, this is internal.
Yeah, but
no,
then
if you look his signature function for the main function, the entry function, it returns list, right? See, list integer. So they are looking for list. But in case if you are using C++ where we can use vector, then I think that makes sense.
No, in this case, we talk about the current variable. That's the internal one.
But actually, why he is doing that internal one? Because he is adding that to the main list, which is going to return, right?
Yeah, he's gonna convert that integer array to the list, when it meet the condition.
Yeah, so Santosh, that in Java, that array list is same like vector in Java.
Oh, really? Okay.
Yeah, it's not actually the linked list.
Oh, okay. I thought it was a linked list. Okay. Because they have something like a list array also, right? So I thought list array was like a vector.
Array list is dynamic in nature. What?
Yeah,
like,
I think it seems similar to vector in C++. But yeah, I mean, that just I wanted to know. It's not related with this problem.
Okay.
Yeah.
Yeah, but yeah, that's a good one. At least could understand how actually he's doing backtracking.
Yeah.
Yeah.
Another way I think we can solve this problem is to use the bit set. Could we use a bit set? Like if we have, like we have 2, we have to select k equal 2, then, at any given time, only 2 bits are on. So we know, at that bit, what would be the answer.
But are you not going to add more overheads to that? Because you have to again maintain that bit set.
Yeah, the bit is smaller, right? Smaller memory footprint than the array of integer.
But then how are you going to use it?
So let's say we have, let's suppose we have only 32 bit, right? But it could be more, but let's say we have 32 bit, and any given time, if we have 2, I think we have 2 on, then I think we correlate that index to the position. So the return will be the answer at this index. So if, for example, in the problem we see the answer 2 and 4, right? So at that time, only bit 2 and bit 4 are on, right?
So how will you keep track? Like, let's say 2 and 4 initially you made 1 1. Next time I have to go for 1 and 4. Then how will you take care of that sequence? Like,
Yeah, then we have to, you know,
one.
See,
at any
Leon.
time only 2 bits are on. So,
Yeah, Leon. Yeah, actually, if you're thinking using a bit set for an index, then it might be difficult, right? Because for how then are you going to represent number 3?
mm,
So that might
0 0 1 1.
actually, yeah.
Okay.
So because you need 2 bits in there, right?
Yeah.
So that might be a bit overhead. Yeah, it might be possible, but we'll have to do some more logic to actually make it working.
Tweaking. Yeah. Yeah.
Yeah.
mm. Because the way I think it's only, either a given number is either on or off, right? So, if it's on, then we pick it.
Okay, so you are trying to say like if you have n, then you map all the number from 1 to n for each
Yeah,
and every
to the
bit.
bit. Yeah.
Okay.
So every time 2 bits will be on, right?
Yeah, he's checking for if there are 2 bits. So you'll have to do a check at the end when you're actually putting that in that solution array or solution list. So we'll have to check that as a base condition.
So then let's say 2 and 4 first time he made it on. So he will have to keep a dictionary where he need to check that no, he has done corresponding to 2 and 4. Now 2
Yeah,
and 3 he
something
has
like
to
that.
take. Then
Yeah, some dictionary if you do, then it might be slightly optimized way.
feasible.
Yeah, but that's a good one to actually think about. Yeah.
Yeah, exactly. The new dimension to thought.
Yeah.
Yeah. Yeah, any queries or shall we proceed to next?
I think Asim left.
Yeah, I think he left.
So yeah, no problem. We can go.
Okay, then let's move to next then. It's a word search too, sequel of 1. So given a 2D board and a list of words from the dictionary, okay, find all the words in the board. Each word must be constructed from letters of sequentially adjacent cell, where adjacent cells are those which are horizontally or vertically neighboring. Okay, the same letter cell may not be used more than once in a word. So this is the matrix that has been given, and these are the words that you need to find whether you can get out of this. Constraint is like if you use you are only supposed to use adjacent, not like O and A. O and this A you can use, this E you can use, and once you have used that, you are not entitled to use it again. So these are the only 2 words possible: this eat and oath. Other than them, P and rain are not possible. Okay, and inputs will consist of A to Z, only small ones, and values of words are distinct here. Yeah. Okay. Your queries or any approach in this?
So when you are saying
Yeah.
we could go only the adjacent ones, it
Yeah.
means we cannot go diagonal.
Yeah, diagonal, only horizontal and vertical.
Yeah.
Yeah.
And also in EAT, if you see that marked as red in the board,
Yeah.
so it is also
Okay.
going in the reverse direction.
Yeah, if somebody will select E, then it can go, I mean, horizontal only. Its left is also horizontal, right?
Yeah, but it's going the other way. It's going from right to left, because usually we always tend to go from left to right, but here you are
Yeah.
allowed to go from
Left to right.
Yeah.
Left to right. Yeah.
So yeah, you need to take care of all the 4 directions.
Exactly. Huh?
Okay.
Other than diagonal.
Mhm.
And you can select each character only once, each
Yeah,
character in a matrix.
Only once for that particular word.
Is it?
So you may use the same character multiple times for different word.
Really?
Yeah.
So
Because eat and oath has T common in that.
yeah.
Exactly. Yeah, makes sense.
Okay.
That means all the characters in the word will be distinct. Then only it's possible, no? Or there can be a word which will have.
No,
There
that's
could be
not true, Sasank, that all the character in a word should be unique. That's not true. It might be
no,
possible that if we have to use the same character multiple times, so that means in the matrix it should be there multiple times.
so they are
Like,
using T in oath.
yeah, take an example. If word is apple, right? So in the matrix, when you make a change, so there should be a p p. So there should be two p adjacent. Then only you can, like, you see that a o a in the
Yeah,
first row.
yeah.
Yeah, so it
Oh
should be
yeah.
similar to like that. So
So but this T is in the same word you can't use T more than once, right?
uh in the same word, this particular t you can't use,
Okay.
but there may be another t which you can use.
Yeah, at that same index, what you use, you cannot use it, but you can use at the other
Yeah.
index. Yeah, okay,
Yeah.
got it.
Oh.
That
So
makes sense. But actually using the same word, okay, for the in another same alphabet for the another word, yeah, that might be some more tricks to do,
so
right?
so let's say oath spelling is OATTH. So first time you use this T. Now you'll see it's at, let's say if we had adjacent T here,
Yeah,
we could have
then
used that, right?
then you can use that.
Okay. Yeah, that was a trickiest one, right? Where adjacent cells are those. No.
I was thinking like whenever we use that alphabet, just mark it or maybe rename it to something different character so that we don't
Yeah,
have to use it. But now he's saying that we can use it for the another word, so we cannot do
Yes.
it. Right?
but I have done the way which you are saying. Like I also use the same thing. Once I've used this T, I'll replace it with has. No, again I replace it with this character after next time. Yeah, it's
You
correct.
mean you are doing the backtracking, right? After using you
Yeah,
marking and okay.
exactly backtrack. So
Hmm.
I'll use T once, put hash, and again I'll put T.
Hmm.
Hmm.
So today we are having all backtracking problems. Okay.
Yeah, exactly. Yeah. So
Yeah, either
yeah,
you can update that or you can use some sort of a widgeted array like what we
Yeah,
use in DFS. Yeah.
visited one, but
normal
that will be
yeah.
overhead, right?
Standard. Yeah.
Yeah.
So yeah, only one set we have to create now, like one extra space.
But if it's a very big array, then it will be a big array space.
Yeah, issue.
Okay. So you are what are you using?
I'm first. Yeah, I'm using try, backtrack, and DFS. Like try. Why I'm using is like let's say I got first time. Okay. Next time if I go down, if I see E, so E is not there here, right? So if I keep a try already, if I check the prefix that this is not a valid letter for this word, then I'll backtrack from there. I don't need to go further for checking INE. I won't go here.
So try is for what? So you are actually putting all the words in the try.
Exactly.
Yeah.
Okay.
Try
I'll put all the. Go ahead.
try is for search actually.
Search. Huh?
Yeah. So when you hit the alphabet and you check in your try, if there is no word start with that, then there is no point to move forward.
Okay.
Further. Yeah.
Makes
I'll
sense.
backtrack from there itself.
Yeah, but
So-
one thing when you said DFS and backtrack, they both are same, right? Either you have a backtrack, which all
Yeah,
involves a DFS, right?
yeah, it's a synonym just
Okay.
DFS backtrack. DFS we generally use for tree and backtrack we generally use for non-tree problems. Like
Okay.
I mean not non-tree, just a name. Nomenclature is same only.
Okay.
Shashank, would you build a
Yeah.
try based on the matrix or based on the words? I didn't
Word.
get it. Okay.
Based on the word, I'll make this try.
And then after that you do the on the for the matrix, what you do?
I'll take each character, go to the matrix and check if it is present, and then we'll apply normal DFS or backtrack what you say. Whenever if I see adjacent character is suitable for this word, then I'll proceed further, or else If I find that, let's say if I go down, E is not here, then I don't need to go further down. I'll just reverse from there itself, and I'll say that this path is not possible. Then I'll go for this one. What do you say? OA. So it's possible. Again, if I go, I find no A. I've already used A. Second A is not required in this because I'll have a try. I'll search there whether could A be the next potential candidate, but it won't. So I'll return from there and go to A and go to this. Actually, that try I'm using for pruning the backtracking. Otherwise, normal DFS and backtrack you could have used to solve this problem. Just to optimize that, I'm using try.
But is it possible to not use try and do the problem?
Yeah,
Yeah, in that
because it's
for
not.
each of the word you have to keep track of, like you have to look up specific index. For example, you found O. So all the neighboring of O in the matrix, you match up with second index in the word list of words, which may be inefficient, and that's why he's using try.
Right.
Okay.
Yeah.
Because
why inefficient? Because I see but O right here match with the first character in the word, right? And I expect the next one will have to be A. And on the matrix, I look at only 4 direction. Which one gonna be A, and I traverse that way.
But so, yeah, that is why try is helping you. Let's say you went O to E, or let's say you went to A. I know that I'll look into the try. I'll see whether should I mean, will A be the potential candidate? No, it can't be a potential. So we'll return from there. So that is helping us to not to go further more down. Or you'll have to do exhaustive search. If you do, you can get it. So you can, avoiding the try also, you can get the things done.
But if I see T, I don't already know I have to backtrack already, right? So I don't even need to try. I already know I have to backtrack. So because T different than A, right?
Yeah, T is different than A. But so when will you backtrack? When the length of your word is equal, or in what would be your condition for returning back? I mean backtracking.
You know, as soon as the character does not match with my current index in, at the word, then I backtrack. So in this case, A different than T. I know I cannot go further. I have to backtrack.
Yeah.
No, backtrack actually, see, there are two things. One is backtrack. What he's using is, if it doesn't find the way Leon is saying, if you don't find in the try, you backtrack. But for even if you have a try, you have to backtrack, right?
Yeah, that's why I question, why the try is useful in here.
Extra leaps would be pruned. Unnecessary leaps would be pruned out. Okay.
Try is more efficient. Plus, like let's say in the list of words, you have you have 10 words, for example, and out of 10 words, 3 words are starting with O.
Same
so then
prefix.
How will you keep track of like multiple words, and within each word within those words, how will you keep track of index? Implementation wise, also try makes it easier.
Right.
And second thing, like let's say you have word oath, and next word is like OATH, PVC. I mean, this as a prefix. So I don't need to unnecessarily again traverse this, right? I'll just look into the try, and I'll follow that path already, which I have constructed, and further we can proceed.
Yeah, my problem of not using try is because try might be a very good efficient way of doing it, but the only problem if I fail to properly implement that in an interview, because try is always, when you try to implement it, you are slightly shaky whether it will really work or not in the first shot. Because in the interview, it's like whatever you do on the whiteboard, it has to work, because someone will point a any issue in your code, and then you are stuck in that, right? You're not able to go through. So try might be a secondary thing. What I would do is I would use all the list of words, what Leon was saying, and do a backtracking for each and every word in the board, each and every letter in the board, right? And so whenever I don't find,
okay, but how will you do that? How will you start with that for each word? Let's pick the word eat, and then how will you start in that board?
Okay, so actually what I would have to do is I will have to take first start visiting each and every letter in the board from rows and columns. Okay, and whenever I find one, I iterate through the list of the words. Okay, to find the first, maybe I'll have to sort the words in that case, right?
No, but what Praveen was saying, that will optimize, right? Let's say he's saying eat. So if we have already tried, we'll
Let's
directly
say,
root.
yeah,
We'll
we
look to
sort the
the
word
root.
and the first word is eat. Now we have to start searching eat in the board.
Right, because see, that will
Exactly.
be the first. See, if eat is there, okay, if it starts with E, so any of the letters in the board character, if they are not starting with E, then
Yeah,
it doesn't matter, right? They are not
right,
going to be in my list.
right.
But first we have to search for E, right?
Yeah. So that is what,
Uh-huh.
anyway, we have to do it. But try will be giving a more efficient solution. That is, I agree, absolutely. But only my problem is when I'm trying to implement it, I'm always shaky about the try.
Oh,
I,
okay.
Yeah,
either the way
Got,
I use it
got
in
your
the
point.
class, or you do it in a different way.
And also try may consume a lot of memory too, because if let lowercase 26 character, right? So in the worst case, when we build a try, how many level gonna be 26, right? And
Yeah,
each of that gonna be.
No, that is debatable actually.
yeah. So I agree that, I mean, try will definitely take space, but that's a trade. So you are doing the trade between the space and the runtime.
Yeah, I think that is very efficient because whenever try problems are there, it means that we are going to have a very big list of words. At least the interviewer might be expecting us to have that sort of test case in our mind.
Otherwise, it's a normal DFS. Even if we don't use try, I mean,
That's
normal
correct.
like just see, check on
Yeah,
the four directions. The first thought that will only comes by seeing this problem. Yeah. Okay.
yeah, both are fine. I mean, if someone sees that, so they should actually discuss both the option and their trade, why, which one, and then based on the interviewer decision, then you have to pick one. If someone says that, okay, I do have a limited resource, limited memory, then you don't have any choice. You will have to go with that, what you, Santosh and you just mentioned. You have to go, whether it will take a day or a year, but you just search with that.
Yeah. So I could at least, give him an approach and say, okay, try can be done it, but I won't be able to implement. I can show you how try is,
Mm-hmm.
in a
Yep.
block diagram form. And this is the way if I use try, this will be optimized. My second loop will be optimized. Something I can tell him. So still,
Yep.
I think that might be able to, for me to get some plus marks there in the interview and just move on, because in 45 minutes you have 30 minutes cramped and then you are so much stressed out to do so many things. I think at that point these things are slightly critical to do. That is just my thoughts.
Another way we can prune DFS is to have another map. So we see E, we every time, the first time we traverse, we see E, we recorded the coordinate, X and I and J, right? So that later we're gonna have a list of like 26 character. I mean, a map of 26 character, and each of that will map to the location where it be, right? Then, at that time we see the word, for example, begin with P, we know exactly, what location we need to do that first search. That way we don't need to traverse the whole matrix again to find where P is.
But there will be many P's.
Yeah, there
Yes,
could be
but
many.
There will be many
in the
P's, right?
matrix, there's only one, that's, I'm saying to, because only 26 character, right? So the
Yeah.
map will be the key of the character and the location where, we can access that character.
So this exact problem, like I faced in real interview, and what I ended up doing is not implement try, and like Leon said, I created a hash map, and the size of the map would max out to 26, and then each of this character, I'll have list of words. So that's how I did little bit of pruning to go after searching.
That's interesting. So you used a
Question.
map And
Let's say at these words, right? I have a hash map, so O will be the key, and oath will be a list of words will contain just oath, and then next one is P is the key and P. If there are more than one, say for example, if there's peacock, then I'll have for key there will be 2 words which will be in the list of words.
Oh, okay. Yeah. So you are actually narrowing it down to with the starting word, starting letter. Okay.
Yeah, but it was not very great improvement, but a little bit, like, because I broke down the like the data set into 26.
Yeah.
If there are 26 like alphabet characters, lowercase.
So if that is like
No,
B.
but SAT is 26. But again, the list may be. I mean,
yeah,
there is no limit for the list.
Yeah, list may be exhaustive. So
it will be exactly same. Say like if you have words here and all the words start with O, so you will have only one element in the set, but the list will have all the word.
That's right.
Yeah,
that's right.
But at most, the size of the list will be equal to the size of the array, right? We only keep track of I and J.
And
I mean, the size of the matrix.
Also, the map approach looks like a shallow implementation of the try. That is how I see it.
Yeah.
Only one level implementation.
Right.
So I think try will help where we'll have word like PEA and PACOCK, right? We have already seen that prefix. So again, we don't.
Yes.
That.
So it went towards try only, right?
But it was like I faced this situation and I felt like in interview setting, writing try and then after solving problem would be too exhaustive and I may not be able to finish. So I was in same dilemma and that's how I ended up doing that.
Oh, that was good, I would say, what you did.
Yeah, with the hash map taking care of.
I have one question, Santosh. So with your try, suppose you found the oath already, and there is another word Othello. Okay, and so how do you ignore? Sorry, let me rephrase. Let me reset my situation. We have oath, the same words here, and the board that is given to us. We have the oath. The match of oath happening at another position, because we already matched oath starting from 0 0. We don't want that to match probably again. So do you remove oath out of your try or do you leave it there?
What?
Actually, see, in the try, you will have only one oath, correct?
Yeah, I'm saying try will have one oath, but the board has the possibility to match it multiple times.
So then you will give 2 oaths.
Word end will be 2 here, like
because the second oath will start at a different index in the board, right?
Yes.
So then you can surely return 2 oaths. That is what I would do.
What I would do is like each word will have as initially 0. The moment you find one oath, you increase it by 1. Next time again, if you see 2. Now let's say you search for the first time and you got oath, decrease it by 1. So 1 oath you got. Next time again you have to get already. Still you have that this is word value as 1. So you can you instead of removing completely oath from there, simply we are playing with the word count. I mean word end, like telling you that 2 times this word has appeared in your.
Okay. I see.
So let's say we have oath, right? OATH, and another one is OATHS. The second one have only extra letter S.
Yeah.
So do we need to traverse it twice or only once?
No, we have to travel twice. We have to, what?
Yeah, you have to traverse twice, right?
Yeah, twice we have to traverse.
See, actually, one thing also in the note, it is mentioned that the value of words are distinct. So we are sure that we are not going to have any duplicates in the words list. But as I think Ace was talking about, right? If we have oath at 2 places, correct? So that is fine because it is still at a different index. We can actually return a same oath twice. That might be a possibility.
Yeah, and the special case, I was not thinking about that. So
Yeah, that's a good
I
one.
don't
Actually.
remember the name, but the say like oath and Othello. So though when we start searching and we reach up to the oath, so we know that we found the word, but still we have to continue. There might be possible that there is another word which actually use oath
Ends
plus
with
something
O.
else.
Yeah, I think there were two things. One is oath and Othello, that is fine. He was fine on that. But he said if oath is coming twice, in the board, right? So I also never thought of it. But as per me, I would think that you return two as an output. One oath first and
Yeah.
second oath.
Yeah,
Exactly.
true. Yeah, because there's no. Oh no, there is a constant. Okay, the word of the.
There is no constraint on the board side.
There's no constant. Yes, you are right. Yeah, that's.
And that is a
I
good
mean,
catch from him, actually. Yeah.
yeah. Then return will output will have the two oath.
Yeah.
So try is helping for that, no? For search.
Oh yeah.
Yeah,
Yeah.
try is helping very efficiently, but as Darshan also said, it's not so easy in the interview.
Yeah, exactly.
I agree to that.
Yeah, that's true.
Because I implement many times try, but every time I get a problem again, I try to implement it takes more time. So I would just
Yeah.
totally ignore it or tell the interview that I will do it at the end. I know try is the best solution, but I will do it this way first.
DFS and using hash map to keep track.
Yeah, or maybe the way he said, you just put a map with starting with any word.
Yeah.
I think it with the oath and oath flow, we don't need to traverse twice, right? Because we already have the try, and by the time we get to the oath and we see that we have a flag and say, okay, this is true, right? But we see that there's still a valid path in the try, right? And if on the matrix we can go to those valid path, then potentially we can find the second valid word.
Yep.
Yeah. That should be fine. Yeah. Okay.
The code is like this. That I defined try. I mean, the nodes will have two things: children, 26 letters that will be off, and this is your is word like flag. What I was saying, whether it will end with that letter or not. If it ends, then it will be true, else false. So this is the insertion process. Like you take the words OATH and initially you put O and then below that A, T, and then H. That is what this is doing. And once you find that you have reached H, there you initialize or is word equal to true, which states that there is a word which is ending with H. And this is for the searching process. Let's say you have to search oath in that. So you'll first go to O and you'll check whether your word is true or not. If it is false, then go below till the point you find that your is word is true. And if you find that it's not true, then you return false. Otherwise, you return this. And here comes the DFS part now. So this is I inserted.
Sorry, I missed. Can you please repeat it from the
Sure,
beginning?
definitely. See, a try will have two pointers. One will have the children, which will keep track of the children, and the is word will be there, which will state whether that particular word ends with the given character or not. Like if oath is there, whether it ends with H or not. If P is there, so once you reach A, there you will end of the word. Once you reach, you will make is word equal to true. Initially, it will be false. So this is the insert function and the search function. Insert function is like you start from the root, take every word, every character of this word, and then append it to the root. I mean, the next children of the root will be your O. Initially, your root will contain empty. Then you will go to O. Then O will have a children as A will have T, and T will have H. And when you reach H, there you say that no, this is the word ending with H. So you'll make the flag equal to true. Now for searching process, how do you go?
One thing, Shashank, in this try, so you are setting this is word when you come out of the loop, right? Of the for loop. Correct.
Yeah,
so it might
that means
be
that
you are going to the next node of after the H. Correct?
Definitely, huh?
So you are going to the next node after H, then you are actually inserting it.
Inserting it, yeah.
Okay. Because if you have something like oath and authorly, whatever they were saying, so
Then
there
from
might be
H,
someone.
Yeah,
I'll
so
start
here,
from O.
yeah, here line number
I'll
11 in Python doing the magic. So if node is not there, it create the node and return it.
Oh, so it is the new node here. Huh?
Yeah, if that node does not exist, then it will create it and return it.
Yeah, from E you will have a new node. I mean, OATH will be same. From E you will create a new node, that this node dot children, and from then LLO. L,
so
else
he
children.
is setting that is word to true at H only. Correct.
Yeah, for
Yes.
H I'll set,
Okay,
and again
sorry.
for Othello I will set.
Okay, sorry. Yeah, then good.
Othello also, because there are two words ending with H and
Each node has a character as well as the
word count, flag,
Yeah.
Boolean. Yeah, sorry.
Okay.
But that will be set only for the end of the word.
End of the word,
Yes.
yeah. So this is your insert, and this is same way I'm saying search. Like you'll go OATH. If you find, whenever you find your is word is true, then you'll return from there. That means that's saying that you're having that word existing with H, ending with H. Now normal, so this is for every word. I'll create that try structure for corresponding to every word, and this is the normal DFS process. I'm starting from here. For every element in your matrix, I'm passing the board, that particular node, the INJ indices, the first indices, and initially this empty string, and this is the final result. So if you find that you node dot is word, that means is word is true. That means you have already reached to the end. You have found the word called H, which is ending with H. So you will append it to your final result and make it as a false. Making false means that you have already visited that word. Next time that is not presenting. If you try to search next time oath, you won't get it, because your end, wherever you, once you reach H, there you'll have is word equal to false, which shows that there is no such word ending with H. And this is like your base condition, I less than 0. I mean, it should be greater than, if it is less than 0 or you are crossing the boundary, I think here it should be I. Yeah, this is, and this is for column, and this, okay, we return in that case. Else I'll pick the first character. I picked it, and I'll search it, node dot children. That means tries children. I'll see where O is in the try. So first character is your O. If you, I mean, not like, if you find that if the first character itself is not there, then you return. Else you replace that particular character with the hash map and check in all the possible directions, up, down, left, right, bottom, and just again, what you say, recurse it and finally update it with the character which you have already seen.
So this is backtracking, the one where you're actually putting that C back. Okay.
Exactly.
Can you explain line 36 again?
Yeah, 30. Yeah, it means like, let's say what I'm doing, node is word. I'm searching for oath, like I'll go to O, A, I found it, T, and H, I found it. So when I found H, there your is word was equal to true, which was stating that you have a word which is ending with H. So you got that word. Now next time you shouldn't visit the same word. I'm stating at H that it is false. That means there is no word ending with H.
Okay, so you mean that if there is second auth in the matrix, so you will still return only one auth, right?
Okay, yeah, exactly. And they're saying duplicate, you will have only distinct ones. The values of the words will be distinct.
No, but in that is only in the words list. But if there is a second auth in the board, then you will return only one.
No,
you will have only searched those words which is present in your words. Take that word and then only will.
So for us, the second oath, he's going to use a second DFS. He's not going to use this DFS, correct? Because at that time the IJ will be different. That will be the top loop, not on this DFS.
Yeah, so in that case, there may be second auth in the matrix somewhere.
Yeah, it might be. So it will
but
going to return another
some
oath.
solution will return only one auth in the list.
No,
because he's actually marking that in the try is actually marking that is word false for auth.
I don't think so. He's marking that in the try.
So let's try
It's
that.
in a
Yeah,
try
yeah.
again.
He marked in the try.
No, he's actually
Try.
just returning it, right? Whether it's a false
No,
condition or
this
not.
nose
That's
dot
a
is word
try.
equal to this one. I'm telling node dot is
Yeah,
word is
this one he's marking that. So when second auth,
you want
his algo will try to search, so he will not find the auth in try at
exactly.
all.
Yeah, because when I reach h, you will see that is word equal to false.
Yeah.
So you don't need to take that again.
But then you still keep
But why do you
going?
have to do that? You don't need to do it, right? Because they said the words is going to be distinct, correct? So words
Yeah,
list
no,
is going to be
in
distinct.
case exactly, but in case let's see if had that condition been not mentioned. Yeah,
Yeah,
I
that
don't
is
think so.
fine. That is fine.
Yeah.
If that condition was not there, then actually using this might be okay. But they are saying that the words are going to be distinct, so you don't need this condition.
Yeah, in case if then I don't need.
So in that case, you might return O twice, because you might have to do that in this problem statement.
Yeah, that is not clear from the statement, but looks like
Right.
maybe the expectation here is that you have to return the word only
No,
once.
it's correct. See, 3 times you are accessing. Like if I don't use that, it is
Okay.
taking oath.
Oh, okay. Yeah. So that is actually so. Okay.
A reason. Yeah.
Got it.
So I mean, next times in the matrix, if you have again oath, I think that also it's repeatedly it's taking oath.
So, but how come he can come to the same point again?
Same point I didn't get.
In the
Auth.
same index,
Yeah, I mean,
yeah. How can we come to O,
Yeah.
O again?
yeah. I mean,
O again.
Because I think if you go on the up, just can you just go up here? No, when you're doing the find words, just go down the find words. See here, when actually you are looking, no, find words, and just when you actually go pass parameters to the DFS, so you go I and C, right?
ING I'm passing.
INJ, sorry. So when you're passing INJ, so it should be just that index, right? So why are you visiting it again and again?
no, actually, now I think what's happening here, because first time when you start with first index, so you find the word from OATH. Now you move to, you try to find the another word. You move to the two neighbors here, A and E. And when you start from A and E, you don't find, then you move to the neighbors O again, I believe.
But then you start with some other one, right? Word, some other letter. So in this example, only O is only one, correct? In the whole board.
Oath is only one.
Yeah, O itself, the letter is only one. So we don't expect any from any of the neighbors to come to it. It might come to O, but it won't be the same word as oath.
I don't think Shashank run the same as the example, because the example there's no repeat oath. He must have run different.
No, he's
the
it's
same.
the same.
He's exactly the same. That is
It won't have any disk. I think it should.
Okay. Maybe we're trying it and see what that issue is. No problem.
So 2 times why it is visiting, right?
Yeah, I didn't understand that the way it is showing in your.
So once you find that is word is true, you are appending it to it, and at the same time you are making it false, right? And
I think when you construct a try, you should not touch it.
See, initially when I went to O, I made it to hash, and again I'm appending the same character to C. So
no, but that is backtracking, right? But you are not going to visit the same index I and J. That is for O. Should not. Maybe I'm wrong.
Let me.
This is just my thought process. Yeah.
You just print out
Maybe
the
DFS, what he's doing, that is actually doing that. But that will happen only when. So let's see. I mean, how actually find words.
Because whenever we do for a DFS, we use visited, right? So here he's not using visited. Correct. That is one thing. That is what I was thinking. If it doesn't use.
Could you please scroll down, Shang? Yeah.
Yeah, sure.
Up little bit. Yeah, that's it. So that's the main logic you have. So you starting your DFS, start actual algo is starting at line 29. Yes. Okay, so here when he's actually entering that, he's not checking whether the starting at ij is valid or not.
Yeah, it should not actually. That's fine. But
So
for DFS, we
that
usually is visited, so you can't come back here.
okay,
But
he's
when we are
passing the
using a
root
try,
and root is not there, then I is this, and then checking if it's return.
or maybe the try is taking care of the is visited.
No, let's say if I don't mark this as false, again it won't check that if node is word, but one.
I think the reason might be the when you backtracking the OATH that will print the oath once, and the next time you backtracking the find the ATH on the board, and OATH will be printed again. So yeah, delete the 36 line. It will print
Appropriate.
false and eat 3 times.
Oh, she's telling when you visit A, then again it's checking for O, right? I mean, checking all the possible.
No, you checking the ATH and you got the node is word is true, so the OATH will print again.
Yeah.
Why would he check the T again?
That isn't that try, you know, he's traversing through the try and he's in the middle of the try, right? And then you're
Yeah. Because each time you reach the end of the word, you have the node is word is true, so you can append it again.
I think it's accurate. That's why it is coming 4 times and it is coming 3 times. This is just because of the try. Yeah, I think.
Yes.
Yeah, that's a good one,
Yeah.
Thank you.
Thank you.
Yeah.
Good
Thanks.
observation.
Yeah.
So how to fix that?
That's the only way now.
You remove this. Yeah. Yeah.
Okay, but we need to think over it properly. Yeah, maybe post a solution on the Slack if whoever gets it.
So
and what is
let's
the
say
real
first time
reason?
it got.
Maybe what he's doing is correct, exactly.
Yeah, but that makes the runtime complexity. Oh, okay. If we set it, or we don't change it, the runtime. Wait, but we still do it again. That would mean the runtime complexity going to go up, right?
No, actually, there's nothing to do with the runtime complexity.
Because like,
can
like
you
this one, it print 3
times.
times. That means it have to go back to A and then it go down again.
Because you're in the middle of that try, right? So you anyway you're going to go there, but it so happens that it is coming there 4 times. It usually comes, right? Because it's going
definitely that will take extra. I mean, increase the runtime complexity as you are actually going with that path again and again.
I didn't get. Once more can you explain like the reason behind that 4 times it was coming?
Yeah, so let's say first time you start with O and you found the word, right?
Okay.
And now you start with the neighbor of O. After finding the word, now you have to explore that is there any word with start with A or E, right? These are the 2 neighbor.
Mm-hmm.
And now when you are E, so now E's neighbor are O and O, T and I. So when you start exploring O, so you found so with E you found that there is no word in the try, so you don't do anything. But when you go A, so there you find I think when you reach T.
So actually you are right. See, Praveen, when you come to A, you will again visit O, correct?
Yeah.
Because you are backtracking in that case. So that at that time the O is open again for A.
No,
that would be infinite recursive if we keep doing that.
it will never end then. But
And therefore
no, that's not the case. It will start only. So what word we have is in the try starting O P. So whenever is there any P nearby?
say no.
Okay, yeah. So when you actually hit E, so there is a starting word E, right? In your word list there is eat, right? So when you
but you can't come to that because your try started with O.
No, Santosh. So what's happening here? So when you actually okay, that's clear that when we start with index 00, so we found the word auth, right? And we return go back to O, and now we start exploring the neighbors, which is A and E.
Oh, okay. When you are saying for the next one, okay, got
Right.
it. Got
Yeah,
it.
and now when we trying to explore the E, so we found that there is a word in our try start with E. So we move to the child in the try, and now we start exploring the neighbor. Is there anything match with that? So it find O, and it does not keep track that my starting alphabet was different than this. So it actually starting from O now.
Yeah, the first part was okay, but when you said when you finished O, ATH, you came back to O, and then you started exploring its neighbors. Okay, so if you have still O as the root, and if you start with E as it's one of his child, so I'm not clear then how, because the try starts with O. Okay, so E
will not be a child of
also, but your root start with EAT, right?
E will not be a child of O, right?
So, but what I think is, like when you go to A again, it has a when you are going fresh, okay, when you finish OATH, you come back and then you go for O's neighbor as A, okay, because you're traversing, right, from the column and row. At that time you come to A, and then you have one of its neighbor as O, because you don't find anything in that words list. Oh no.
Yeah, there is no word starting with.
No,
there is
is
no
some
word
confusion.
starting with A.
Yeah,
We started from O. TH we covered, right? No, when you take neighbor of A, there is no word starting with A, right? That is where we'll return no from there.
No, I think. Okay.
You know what I was thinking? I mean, I think I was wrong, because I was thinking that the first alphabet it will find there is a word starting with E, and then that node does not. There is no word in the try which has the second alphabet O.
I think Emily can once more like.
Shasha,
Yeah.
could you do some test to find out the reason? You can change the line 31, the self DFS board node IJ. You change the IJ to 00. That means we only start with 0 position, and you comment out the 36, and run it to see what will be printed out.
6 times, 7 times, infinity. It's like.
Yeah. You always starting from auth.
Yeah.
That means you just come out to the for loop. Yeah, 29 and 30. Yeah.
I don't know one thing in this DFS on line 35 and 36. When he has done with that, should he not return from the DFS here? Is he returning here? Because if you don't return, then it will go in the infinite loop, right?
No, I mean, if he will return, then how he will handle the scenario where auth and Othello.
No, just do like Emily say, right? But run the 00 only once.
Yes.
Right? So we can track and see, where they repeat it.
Yeah.
So you'll have to remove from that, yeah.
Yeah, come out to the yes.
That will come out only from one loop.
Yeah.
Yeah, she wants that only.
No, stop right there too. Just like return, for example, so we can see what it print out.
Is
that?
Is it?
Or you can just remove those 2 for loops.
Yeah. Remove for loop or break. Yeah, either way will be okay. Yeah.
Break should also have worked then. because
Yeah, it's
let's
okay. But
Yeah,
we
break
understand this.
yeah,
We
works.
don't understand Python, right?
Yeah.
So that's the problem.
How about the indentation? Yeah, because
yeah, definitely. Again, I have to. It's better to use break, I think. Then I don't
yeah,
have to indent everything.
yeah.
Okay.
Yeah, it's okay.
We are illiterate.
Yeah. Same thing.
It's also
Yeah, it's also infinite.
No, so there is some problem. We need to actually really find out. Yeah.
That give a lot of information there.
Yeah. Okay. No problem. I think I'll also work on this. And if anyone gets some input, please share on the Slack. Sorry.
Yeah.
I like
Stack.
sorry.
Okay.
Okay. It was a really good discussion and a lot of
brainstorming. Lot of brainstorming was there. Yeah.
Yeah.
It should.
But surprisingly, that trick is make it run, efficiently and pass the test.
Yeah, it passed, and it is very important actually, So we should really understand that. That will be very helpful for us in future.
There is another way to implement the tray. Instead of use the is word to mark the end of the word, you can create a string parameter in the try. And if you only get to the whole word in the board, you just erase that word in your try. So you needn't do the search again on the board. Yeah, that's the way to solve this problem.
Okay, so when you come to the end of the word, you can always check that word.
Yes, you have a string parameter in your try.
Yeah.
And if you got the word on the board, you erase that string in your try. Remove the word from your try. And next time you traverse the board, you needn't search that word again.
Yeah. Yeah, I think that might work, but we still need to find out why it is actually working and what actually is lacking, right?
Yeah.
Yeah.
It's
So yeah, I
interesting.
understand that might be a very brilliant way of implementing. But what is the root cause? Yeah, should be. There should be some way to understand that.
Yeah.
Can you paste this code on Slack group?
Yeah, sure.
Please, thank you.
Okay. Yeah, Shashank, thank you.
Thank you, guys.
Thank you, Praveen. Thank you, Leah.
Thank you, guys.
Thanks.
Thank you.
Thanks. But the mystery is yet to be.
Yeah, we'll do that. Don't worry. We'll
Mystery
find
is yet to be resolved, I think.
Yeah, you have done it, but we just want to find what that issue is. Yeah. Good.
Yeah. Okay. 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 Thank you. Thanks. I'll paste that code.
Let's make sure stop record.
Yeah.